Hi, I am the PC expert amateur, and I'd like to delve a little bit into the measurement of static pressure and how it affects what the fan can and can't do. So, one of the things I've often discovered with fans is that two things, actually. Two things. The first is that when I am using my hand to evaluate the fan's static pressure, which is a very, very, very crude method of doing it, but I'm kind of good at it because I've observed where 1 is and where 2 is and where 3 is. And so I can give a rough estimate. I can't give anything precise, of course, but I can give a rough estimate. But what I've noticed is if you sit in front of, say, your fan at home, there's depending on the fan, there's generally, however, a consistent amount of pressure across the entire cross-section of the cone of air that's coming at you. With PC fans, I often notice that is not the case, that there is usually more pressure along the outside of the cone than in the middle. Sometimes a hugely different amount of static pressure. And other fans will have a more even pressure across, but still most of the PC fans that I've looked at, I find that I'm most likely to find the peak static pressure along the outer edge of the air cone or the airflow cone. And that is a problem. And the reason why is because it depends on what you're using the fan for. So if you are using a fan on a dust filter, it's going to be pulling air in through that dust filter. More air will collect where there's more static pressure. More air will be pulled through. And more dust will collect in that area as well. Depending on how dusty your room is, will determine how rapidly that dust builds up. But more importantly, if you put this on an air cooler's heatsink or a water cooler's radiator, there are going to be parts of the fin array that are cooled better than other parts, which is to say there's more air being pushed through at a time than other parts, so you're going to get uneven cooling in the fin stack. I don't know if you understand what I mean by that, but okay, so this is a radiator, for example, and you can see me through it, right? Not very well, but you can see. And the gaps between these fins are fairly large for a radiator, but that's okay. Some radiators are thinner, some are thicker. Some have bigger spaces between all the fins, and some have smaller spaces. The thicker a radiator is, the thicker the more dense it is in here, denser, the density of the fin array in here will determine how much static pressure is needed to actually push air all the way through in large enough volumes to make a difference to keep this cool. Because all the heat from your CPU is being transferred to here, and you need to get it neutralized in here as quickly as possible by pumping air through it. So the faster you're pushing colder air through here, the faster that the water is moving through here as well. There's obviously limits as far as how fast you want to go, but speed of airflow, speed of water flow are both important in determining how much heat dissipation you're going to get from your radiator or also your heatsink. And this is a heatsink. Now, one thing you'll notice with heatsinks versus radiators is often the many brands, they don't, unlike this Noctua U12A, which has a closed off side, or mostly closed off anyways. You can see that the radiator sides are definitely closed off completely. This is better than an open-sided heatsink, and an open-sided heatsink is going to give you the worst results in terms of performance because some of the air is going to escape out the sides instead of cooling the opposite side from the fan, which is why 2 fans are better than 1 because it helps make sure that the air goes all the way through. Generally speaking. Now, if you get a powerful enough fan, like if you put a Fantex T130 here and don't have another fan here, it'll be better than 2 of these A12 by 25s. It'll do a better job. I know because I've tested it. So, and you can see that the gaps between these fins have somewhat less density than this radiator. So when you take this fan and you put it against this radiator and you mount it correctly, assuming there are no gaps between the fan and the radiator, which is going to cause a loss of pressure, reduced airflow, it's going to push as much air as it can through the radiator. Now I'm going to turn this one on. And this is the input side is next to my hand, and this is the output side. And I can feel it. When I feel it, where do I feel it the most? Well, way down here. Because this one has a cone that's going out like this. Better fans have a cone that's going out at a much more obtuse angle than this, a very, very acute angle of this particular fan. And then when I get beyond that point, I can still feel some pressure, but there's less pressure closer to the hub than there is at the edge. And that means that when I apply this to the radiator, assuming that you can get it flush, you're going to feel more airflow around this area here than the inner areas. That means that this part of the radiator will be hotter than this part of the radiator. And the same is true with the heatsink. Because the pressure is not being distributed equally across the entire airflow cone by the fan. So we get unequal cooling. And that is one of the reasons why oftentimes a fan is needed that has, for me, I don't recommend personally any fan with less than 3 millimeters of water static pressure, because it's just not enough, especially if it's not equally distributing the static pressure across the entire air cone, the airflow cone. So how do we know? Well, it's not hard to know if the fan is distributing the air equally or not. It's actually very easy. You can, as I've learned by testing so many different fans with my hand, I've learned where to put my hand based on how much pressure I'm feeling. And that tells me the static pressure at that point in the air cone. All right. So this is about 1, something like that, right? And if the box says 2.5, but I only feel 1 or 1.5 or 2, that tells me that there's a very unequal distribution of airflow by the static pressure. That it's mostly, usually, on the peripheries of the airflow cone rather than in the middle. So it's not ideal. But most fans, and there are exceptions like NZXT 120 RGB and RGB Duo. Their pressure is very unequal. The outside edge of the airflow cone has not got as much air, static pressure as you would expect, which hopefully means that the pressure inside of the airflow cone is going to be about the same. But when I feel it, it doesn't feel the same. It feels like even less than along the periphery or the outer circumference. So how can that be that they measured 2.4, say, but I only feel 1.5? Well, there's three possibilities. One, they didn't correctly test, or they have bad equipment. Two, they lied. Or three, when they hook it up with all of the airflow of the fan being trapped into a cone that goes into a tube that goes into a manometer, or goes through a tube where there is a digital manometer that's picking up airflow in one area of the whole cross section of the tube. Well, what do you think is going to happen? It's not going to say, well, in the middle, the pressure is 0.5, but on the edge, wow, it's 5. It's going to say 2.4, if that's what it really is. So this presents us as users with a problem, because we are getting a product that overall has more static pressure but is not being applied equally across the entire cross section of the airflow cone, which means better cooling usually around the edge and worse cooling in the middle. Now, I guess you could design something that is a series of sensors that picks up the static pressure at each point. How you would do that exactly? I mean, you could do the thermistors, which actually measure temperature. You could have a series of thermistors going from the very middle of and you'd want to use a tube or something. But then you could run into the problem, like with this fan, you run into the problem that the cone is so large that you'd have to have 20, 30, maybe 40 thermistors going through the entire cone. And that is not practical. So you could do half of the cone, because in theory, at least, if with half the cone, you're still going to get all the information you need, and you can flip that to the top half of the cone that you're not measuring and say, okay, these are the measurements I got down here. Flip them in reverse, and that's the same thing up there. So it's a mirror image, right? So still, you're looking at maybe 20 thermistors. Another way would be to have something that responds to physical pressure. So maybe it's got things on, I don't know how you would devise a pressure sensitive device that responds to physical pressure with enough sensitivity that you could get a very accurate measurement. But it's same basic idea. You're going to have a series of those sensors catching the wind as it passes by, and it'll show, okay, down here it's 3, here it's like 2, here it's like 0.5, 0.3, whatever it is. Or maybe it's 3, all the way to the hub, and then near the hub it drops off because the hub is a dead space. And I haven't, in my searches for an anemometer that can measure airflow and a manometer that can measure static pressure, I haven't come across that kind of tool, but that doesn't mean it doesn't exist. But maybe nobody's ever thought of it, or maybe nobody's ever figured out how to make it, or maybe nobody feels like it's important, and maybe it's not important. Maybe it's not really possible with small fans like you put into a PC to actually have them have consistent static pressure across the entire cross-section of the airflow cone? I don't know. What do you guys think? Are there any people out there that know a lot about airflow and static pressure, fluid dynamics, maybe? What do you think would be the best way to measure the entire cross-section from the hub to the edge of a cone, moving from right next to it out to however far you have to go to see how far it's actually blowing at pressure or at a significant enough pressure? But it'd be interesting if somebody can figure that one out. So I just wanted to share that information, those thoughts with you, and who knows, maybe some inventor is going to come up with the solution. I can't imagine that it'll be cheap, but it'd give us a much better understanding of how these fans are working in terms of static pressure and air, and thus the airflow that's being put through each part of a radiator or heatsink or dust filter by a particular fan. Thanks for watching and have a great day.